Hello students, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today in this video, I am going to discuss about the concept of circles in two dimensions in terms of coordinate geometry. Now circles can be studied in terms of plane geometry, that is simple geometry, which are in class 9-10 syllabus, or it can be studied in terms of coordinate geometry. These are for students of class 11 and 12. Now in this session, I am focusing my lecture to study circles in terms of coordinate geometry. That is, these lectures are intended for students of class 11 and 12. So how do we define a circle in two dimension? Two dimension means a plane. So on a plane, a circle may be defined as the locus of a point, as the locus of a moving point whose distance from another fixed point on that plane always remains the same. This is how we can define a circle in two dimension. So to elaborate the concept, let us consider a fixed point on this plane. So this is a two-dimensional plane. So on this plane, let us consider a fixed point. Say this is a point O. So this point is fixed. That means it cannot change its position. And say we have another point P, which is a variable point. So this point can move on this plane. P is a variable point. Now if this point P moves in such a manner that its distance from this fixed point O, this distance PO, always remains the same. So the point P moves along such a path that for each and every position of P, distance of P from the fixed point O always remains the same. Then the locus of P, locus means the path along which the point P travels, then the locus of the point P is defined to be a circle in two dimension. So which means the locus should be something like this. So here we see that as P travels along this path, for each and every position, distance of P from the point O remains the same. So these distances are all equal. That means if we mark the successive positions of P as say P dashed, then P double dashed, here say P double dashed, P triple dashed, and so on. So we have OP is equal to OP dashed, is equal to OP dashed, is equal to OP P triple dashed, and so on. So then this locus, this path of P is said to be a circle. So a circle in two dimension may be defined by the locus or path of a moving point which maintains a constant distance from another fixed point on the same plane. So this is how we define a circle on 2D. Now let us try to find the equation to such a circle in two dimension. So how to find the equation in such a circle, of such a circle in 2D. So say this is our coordinate frame of axis, that is x-axis and y-axis, and say we have a circle here with center given at O, and say the center is given to be alpha beta. These are the coordinates of the center. The coordinates of the center are known, that is alpha comma beta. Now we have to determine the equation to this circle. Now as we know that to find the equation of a curve means to establish a common property which each and every point on this curve will satisfy. That means if I choose a variable point, say P, on the circle itself, x comma y, so P is an arbitrary point on the circle itself, x comma y. Arbitrary means its position we can choose anywhere on the circle. So to find the equation of this circle, we are to establish a relation among x and y which should be satisfied, which should be obeyed by each and every points on this locus. then that relation between x and y may be defined as the equation to this circle. So how to establish such a relation? So as for a circle, we know that the distance of P from the center is always constant, and if we consider this constant to be r units, so these parameters are known, that center coordinates of center are known alpha comma beta, and the distance of the center from the circumference is also known as r. If these parameters alpha beta r are known, then from the diagram, as we can see, distance of OP is given by r, which is radius of the circle, and applying distance formula between O and P, the distance between OP is given by under root x minus alpha whole square plus y minus beta whole square. So this is given by r. This is the distance formula between 2 points x1 y1 and x2 y2, root over of x2 minus x1 whole square plus y2 minus y1 whole square. So this becomes equal to r. Or if I square both sides just to get rid of the radical sign, so squaring both sides, finally we obtain x minus alpha whole square plus y minus beta whole square is equal to r square. So here we establish a relation between x and y which is satisfied by each and every point on this path, because wherever we may choose the point P, the same property will always hold, OP will always be equal to R. So this relation is universal, or this relation is unique for each and every point on this locus, on this path. So hence this defines the equation to this circle, and this particular form of the equation is known as the central form of a circle, equation of a circle in central form. Why such a name? Because from this equation we can directly find the center and the radius. The coordinates of center are visible here, alpha beta, and r is the radius, hence such a name. This is known as the equation of a circle in central form. So whenever we have the coordinates of center of a circle and the radius of a circle, its equation can be found in central form as x minus alpha whole square plus y minus beta whole square is equal to r square, where alpha beta denotes the coordinates of center and r is the radius. And here xy represents coordinates of any point on the circle. So here xy represents an arbitrary point on the circle. So this is the equation of a circle in central form. Now let us derive the general equation of a circle. There is another form of equation of a circle which is known as the general equation, which is nothing but a little simplification of the central form itself. So from the central form, so if I consider this equation of a circle in the central form, which is given by x minus alpha whole square plus y minus beta whole square is equal to r square. If I apply the binomial expansions now for x minus alpha whole square and y minus beta whole square, so we have x square minus twice alpha x plus alpha square, then plus y square minus twice beta y plus beta square is equal to r square. This is applying the binomial expansion for these two terms. Now if I regroup some terms, if I rearrange some terms, if first let us arrange the quadratic terms, x square plus y square. These are the two quadratic terms. Then the linear term x and y containing term minus twice alpha x minus twice beta y, and finally the constant terms, that is xy independent terms, that is alpha square plus beta square and minus r square, shifting r square on the left hand side. So we have minus r square is equal to 0. or the equation can again be written as x square plus y square plus 2 times minus alpha into x. We are writing minus 2 alpha x as plus 2 times minus alpha into x. Similarly, minus 2 beta y as plus 2 times minus beta into y, and finally plus alpha square plus beta square minus r square is equal to 0. Which implies x square plus y square plus twice gx. Let us now rename this constant minus alpha by g, another variable g. Sorry, it isn't a constant. Let us recall this constant minus alpha by g. We are just renaming it. Similarly, plus twice fy, we are naming minus beta by f, and plus c, the whole constant term, we are naming this by c, is equal to 0. So here g stands for minus alpha, f stands for minus beta, and c stands for alpha square plus beta square minus r square. These are the values of g, f and c. Then finally the central equation, the equation in the central form, which was given by x minus alpha whole square plus y minus beta whole square equal to r square, takes this form. X square plus y square plus 2gx plus 2fy plus c is equal to 0. So this form is known as the equation of the circle in general form. This is the equation of a circle in general form. Now in general form, from this equation, if we have to obtain the coordinates of the center, then what will be the coordinates of the center? As the center basically remains the same, because both the equation represents the same circle. So for this circle the center was alpha beta. So here also the coordinates of center in terms of g and f. So since the coordinates of the center are alpha beta, alpha in terms of g becomes minus g, because if minus alpha is g, then alpha becomes minus g, and beta in terms of f is given by minus f. So the coordinates of the center in terms of g and f is given by minus g minus f. Because here we don't have the parameters alpha beta, instead we have g, f and c. So we have to express the coordinates of center in terms of g and f instead of alpha beta. Those are given by minus g and minus f. And similarly the radius which was r units can be given by root over of g square plus f square minus of c. You can simply calculate this. If you substitute the values of g, f and c from here, you will see this expression will come out to be r. So in general form, the center of the circle is given by minus g minus f. These are the coordinates of center, and the radius is given by root over of g square plus f square minus c. So now we have equation of a circle in central form and also equation of a circle in general form. Now these two forms have their applications basically these two forms are just reverse of each other. What I mean by this is, when the equation of a circle is given, and we have to find the center and radius, then we take the use of the general form. So the general form we just obtained is given by x square plus y square plus 2gx plus 2fy plus c is equal to 0. And here the center, coordinates of center are given by minus g minus f, and length of the radius is given by root over of g square plus f square minus c. So this general form When we use the general form, when the equation of the circle is given and we have to find the coordinates of center and radius, then this form is useful. Whereas if the center and radius are known and we have to find the equation just the opposite way, if center of a circle, coordinates of center are known to be alpha beta and radius, the length of radius is given to be r, then to find the equation we use the central form. Then the equation of the circle is given by x minus alpha whole square plus y minus beta whole square is equal to r square. So these two forms are just opposite to each other. In the central form of equation is used to obtain the equation of the circle when the center and radius are known. Whereas here, when the equation of the circle is given and we are to obtain the coordinates of center and radius, then the general equation is used. For example, to elaborate the concept, say we have to find the equation of a circle with center as 1, 2 and radius as 3 units. The problem is to find the equation of a circle with center at the point 1, 2, so coordinates of center are known and the radius equal to 3 units. So then we apply the central form. The equation is then given by x minus, here alpha is 1. So the equation is given by x minus 1 whole square, this is alpha, beta is 2, so plus y minus 2 whole square is equal to r square, r is 3, so 3 square. After expansion, finally we have the equation x square plus y square minus 2x minus 4y, and the constant term would be 4 plus 1, 5, and here we have 9, so 5 minus 9, which is minus 4, is equal to 0. So this is the equation of the circle. So when the coordinates of center are known and the radius is known, we can find the equation of circle by using the central formula. This is the equation in central form. And when a circle is given, when the equation of a circle is given and we are to obtain its center and radius, then we have to use the general form. So let me show you an example. Now the equation of a circle is given. Say x square plus y square minus 6x plus 8y minus 1 is equal to 0. So this is a circle. Now from here we have to obtain the coordinates of its center and radius. So if we compare this equation, with the equation of a circle in general form, so the equation in general form was x square plus y square plus 2gx plus 2fy plus c is equal to 0. So comparing these two equations, we have 2gx is given by minus 6x. If I compare the x terms, so we have 2gx is equal to minus 6x. So from here we have g is equal to minus 3 if I cancel x and 2 from both sides. And also comparing the y terms, we have 2fy is equal to 8y, the y terms 2fy is equal to 8y, so which gives us f is equal to 4. And finally comparing the constant terms, c comes out to be minus 1, c is equal to minus 1. Mind that we have to consider the sign also while comparing the terms. So these are g, f and c. So as per the formula, the coordinates of center are thus given by minus g minus f, which are given by 3 comma minus 4, and the radius is given by root over of g square plus f square minus c, which thus becomes g square is 9 plus f square is 16 minus of c. So c is minus 1, so this becomes minus of minus 1, so which is basically root over of 26. So much units. So the coordinates of center are given by 3 minus 4 and the radius is given by root 26 units. So this is how we can obtain the center and radius of a circle whose equation is known. Now, as we see here that the equation of a circle is finally given by a second degree equation in x and y. So let us study the condition under which such an equation of second degree in x and y will represent a circle. So let me just state the condition under which the general equation of second degree in two variables will represent a circle. Now the general equation of second degree is given by ax square plus twice hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is the most general equation of second degree in two variables x and y. So here we have an x square term, an xy product term, a y square term, an x term, a y term and a constant term. So this equation will represent a circle if coefficient of x square is equal to coefficient of y square and they should not be 0. This is the first condition. Coefficient of x square term must be equal to coefficient of y square and both of them should not be 0. And there should not be any product term xy, that is coefficient of the product term xy must be also 0. So a general equation of second degree in xy will represent a circle if the coefficient of x square is equal to coefficient of y square and both of them should be non-zero. That is, in this case we have a equal to b not equal to 0, and the second condition is there should not be any product term xy in the equation, that is the coefficient of xy h must be equal to 0. So these are the conditions under which the general equation of second degree will represent a circle. For example, we may have such an equation 3x square plus 3y square minus 5x plus 8y minus 6 is equal to 0. So as we see here that we have an equation of second degree where the coefficient of x square is equal to coefficient of y square, both are non-zero and they are equal, and there is no product term xy in the equation, so coefficient of xy is 0. So hence this equation represents a circle. Now, to obtain the center and radius of this circle, if we are to obtain the center and radius of this circle, first we have to divide the both sides of the equation by 3. This is a very vital point, because to obtain the center and radius of this circle, we have to compare this with the general form. The equation to the general form of a circle, as we discussed earlier, the equation to the general form of a circle is given by x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the general equation of a circle. And say if I rewrite the equation here, and here we have the circle, say let us take another equation, say 3x square plus 3y square minus 6x plus 8y minus 9 is equal to 0. So as we can see that this represents a circle, the both conditions being satisfied, coefficient of x square equal to coefficient of y square not equal to 0, and there is no product term xy, so this is a circle. Now to find the center and radius of this circle, first we have to divide both sides by 3, because in the general equation the coefficient of x square and y square are both unity, they are both 1. So whenever we have to obtain the center and radius of a circle, first we have to make the coefficients of x square and y square unity. So hence we have to divide both sides by 3. So dividing by 3 gives us x square plus y square minus 2x plus 8 upon 3y minus 3 is equal to 0. Then only we can compare this with the general equation. So now comparing with the general equation, we cannot compare this equation with the general equation, because as you can see that 3x square cannot be equal to x square, 3y square cannot be equal to y square. So unless we make the coefficients of x square and y square unity, we cannot proceed to find g, f and c. You should remember this one. Students in maximum cases does mistakes here, that they directly compare the x term and y term from this equation only. But unless you reduce the coefficients of x square and y square to unity, we cannot proceed to find g, f and c. So now comparing the x containing terms, we have minus 2x is equal to 2gx, giving g equal to minus 1. And comparing the y terms, we have 8 upon 3y is equal to 2fy, which gives f as 4 upon 3. Hence the center is given by minus g and minus f. Thus the coordinates of center becomes 1 minus 4 by 3. And also we can similarly find the radius. Here c is given by minus 3, and applying the formula to radius will be given by root over of g square plus f square minus c. So this is how to obtain the center and radius of a circle whose equation is given in general form. So in today's lecture, basically what we have discussed is the very concept of a circle, the definition of a circle in 2 dimensions, and we have defined the 2 forms of a circle, the 2 forms of the equation of a circle. The first one is the central form, the second one is the general form. And also we have discussed their applications. That is, the equation of a circle in central form is used when the coordinates of center and radius are known and we are to obtain the equation. Then the equation of central form is used. And the general form is used when the equation of the circle is known and we are to obtain the coordinates of the center and radius. And also we have discussed the condition under which the general equation of second degree may represent a circle. We shall continue our further discussion in our upcoming videos. I hope today's lecture is clear to you all. If you have any questions, you can ask me in the comment section. And if you like this video, please feel free to subscribe my channel. It will help my channel to grow. Thank you all. Have a nice day. We shall meet soon in my next video. Thank you.